Okay, so here is the Unit 5, Day 9 CFU video explained. So just a quick note, in the previous video where I left you with the answer key, this is actually the correct answer for number 1. There was a mistake there. That should have been sodium nitrate, not potassium nitrate. But at any rate, so I'm just going to quickly explain how we do this. In a precipitate reaction, you start with two ionic compounds. Ionic compounds are made up of a cation, metal, or it can be NH4 plus ammonium, which is seen in example 3 at the top. So it's either going to be a metal or it's going to be ammonium. All right, so you start with that, and then the other part of the ionic compound is the non-metal anion. All right, and in a precipitate reaction, you switch the cation of the first ionic compound with the anion of the second, so the first and the last go together, and then you switch the cation of the second with the anion of the first, so the two middle parts go together, but you got to write the metal first, and that's how you form that product. All right, and then the last thing that you need to do is just make sure that the overall charges of your compounds are equal to 0 to make sure your formula is correct. So in this first example, aluminum, which is in group 13, it has a +3 charge. Phosphate, which is on the polyatomic ion chart, has a -3 charge. So just to show you all that, here's aluminum with its +3 charge, because it's in group 13, so it's +3 charge. And then for phosphate, it has a -3 charge. It's over here. If you add those two charges up together, they're going to give you 0. So +3 and -3 added together gives you 0, and that's what we want. So that means that we just need 1 aluminum and 1 phosphate, and that's the chemical formula. For sodium nitrate, our second product, sodium is in group 1. And then nitrate is over here in the polyatomic. It has a -1 charge. So sodium has a +1 because it's in group 1. Nitrate has a -1 because that's the charge that it has, according to our polyatomic ion table. If you add these two together, it gives you overall 0 charge, so this is good. Okay, for the next example, we have these two products. So nickel is a transition metal, right? For transition metals, you have to figure out their charges. To do that, first of all, let me back up. We form these two products by switching, just like we've done before, so that part is pretty straightforward. But to figure out if these are the correct formulas, we would look on the periodic table. Nickel is a transition metal, so we got to figure out the charge. To figure out the charge, you go back to the reactant. Nickel is found in this first reactant here. And we don't know the charge on nickel, but we do know the overall charge must be 0. Now fluorine, the anion, we can figure out the charge of fluorine because it's in group 17. Here it is, so it's got a -1 charge. And we've got 2 of them. So that means the overall charge here for the anion is going to be -2. So I got to figure out, well, what charge must the nickel be in order for the overall charge to be to be 0. That means that nickel must be a +2 charge. Okay, and so that means my nickel's a +2 charge. Now, if nickel's a +2, well, let's go over to the periodic table to find for an anion. It has a -2 charge. So this overall charge is 0 now. So that's the formula is good. And then for potassium, it's in group 1. And fluorine is in group 17, so it's a -1. So we've got a +1 charge and a -1 charge. This one is good too. Okay. I'm just going to quickly go through the rest of these. So potassium is in group 1. It has a +1 charge. Nitrate, if you look on this table, you will find that it has a -1 charge. The overall charge here is 0, so that's the correct formula. Sodium is +1. Chlorine has a -1 charge. Again, for these, you would look on the periodic table and find them. Here's sodium with its +1 charge. Here's chlorine with its -1 charge. Barium is in group 2, so it has a +2 charge. Sulfate has a -2 charge if you look on the chart here, you will find that sulfate has a -2 charge. Here's sulfate. Okay, so that formula is correct. Copper, you have to figure out the charge because it's a transition metal. So once again, to figure out the charge of the transition metal, you go back to the reactant. You know the overall charge of that reactant must be 0. The anion part, sulfate, has a -2 charge. So you're asking yourself, well, what plus -2 will give me 0? And the answer to that is +2. So we figure that one's +2. So we know copper has a +2 charge. Each hydroxide has a -1 charge. So the hydroxides have a -1 charge. So when you first wrote this out, you would have written CuOH, right? And then you would say, oh, wait a second. +2 and a -2, that doesn't cancel out to give me overall 0 charge. So how many hydroxides do we need to get an overall 0 charge? We need 2 of them. And then since we need 2 of them, we put a parentheses around the hydroxide and then a 2 on the outside. All right. Now, one quick note. You may be thinking, oh, I just switched the parentheses OH2 with the copper. Like I just switched this as is. You can't do that. So far in the examples that we've seen, you haven't been tripped up, but believe me, that's not always the case. So these examples are kind of easy-ish to sort of ease you into this, but you can't just switch them. And that's because what you're doing in a precipitate reaction, you're switching partners, but not the number of partners. The number of partners will depend on the overall ionic charge. And sometimes that won't work. So you can't just rewrite what's written over here on the left side onto the right side. You have to figure out how many you need based on the charges. So just keep that in mind. Final example, we have copper carbonate as our product and sodium chloride as our product. And once again, we have to make sure this is the correct formula. For copper, we have to figure it out based on this side of on the reactant side. So copper, we figure out that its ionic charge must be +2. Since each chlorine has a -1 charge. So the charge on copper must be +2. Carbonate, if you look in the polyatomic, here it is, carbonate has a -2, so this formula is correct. And then finally for sodium, it's in group 1. Chlorine is in group 17, so those are their common charges, so this formula is correct. All right, so that is it. This is how we do this. Now, in the next videos, we're going to go over strategies for balancing these equations.